whatever. It's a fashion business.
So yeah, anyway, I just started the recording. So just to remind you, this is the Ontology Summit 2020 Fall Series. Today is October 30th, 2019, and we are currently discussing knowledge graphs. The question is, what's really new about them? And so it's hard to see that there's anything, as you say, new about the representation. What appears to be the essential difference, if there is one, is in this tooling and the areas like big data, machine learning, and many companies coming along and starting to produce proprietary products related to these standards. I'm reminded of some discussions I had at an early summit with some people who were there.
Yes.
And they made an interesting point. They said, this is a great field, but ditch the name ontology. They said that just scares people. And so maybe this is what's happening. The people in companies are realizing that marketing with the name ontology, with the ontology, just isn't working. So they came up with a new word.
Kenneth?
Yes?
What is the new word?
There is one difference in the use of knowledge. Well, there could be one distinction that is of note with regard to knowledge graphs in contrast to relational databases, in that if you have a real ontology, I'm being a snob here, then you have more explicit representation of the entities and their relationships in the domain that you do not have in other persistence mechanisms. Now, I realize that many people that are using knowledge graphs don't take that to heart greatly, but I think it is one distinguishing factor we should keep in mind.
Right, but that's relational databases versus ontologies and RDF graphs, not the distinction between ontologies and knowledge graphs.
Right, but there was an argument made that there's not much new in terms of using knowledge graphs, and I thought the implicit assumption was in comparison to relational databases.
Okay, that you could make a case for that. Perhaps that's what we should do.
Is Jans with us today? Ken?
Unfortunately, although he agreed to come today, and then I sent email reminding him, and unfortunately he doesn't appear to have remembered or was unable to come. So I'm going over some of his slides. Here's one of them.
Maybe you want to remind him one more time by email at his email address, just in case.
I'll send him once more.
Thank you, sir.
I think David's point from the chat is also important, that that there have been various brandings. Ontologies was a branding. Semantic web was a branding. Connected data was a branding. And so each of these maybe has its hype cycle and needs to be replaced by something else when people become discouraged at how difficult it is to make progress. I do think that we're at a tipping point with this knowledge graph branding. And then the question just is, you're going to face all of the same challenges that one faces with ontologies. And so that's where we are.
Okay, this is Paul again.
Go ahead.
I'm sorry, I don't know everyone's voices. I think it was David was talking about ontologies. I would say maybe differences between implied ontologies and explicit ontologies. it was a turning point in my career when I realized that all enterprises, if they're still in business, have an implied ontology that describes their environment. It's represented in various possibly degenerate ways in their various IT systems, but nevertheless, it's there and it's a working ontology.
It's not very useful. And
Well, it depends. Okay, let's go with that. Why isn't it useful? It's a fact that there is that they have to you know they to do business they have to have some agreement on what's what in their environment.
yes, some
Now, why
agreement.
isn't it useful? Well, one big thing is the data silos. It's buried. It's not obvious. So first thing I did once I realized that was take advantage of some of the RDF tool stack and make that more available, but only to the point of need. I dropped any notion of a universal ontology. No matter how much I wanted it, these people were not going to start putting their data into, say, STEP at that time. So it was big in the product modeling realm. So I abandoned that notion and just said, let's work with what we got, use the technologies we have to make whatever they're doing more useful.
And
so that's when I started making progress with what's now called knowledge graphs and relating information from different data sources, trying to bring to the surface these implied ontologies and rules that the business ran by, and not fretting about putting it into some universal standard or anything like that.
well, that's an adequate practical approach to it. The only problem you may run into is if you try to extend it. If your company merges with somebody else or they acquire some other data sources that they have to fiddle with, then it may be a problem, or not. I don't know. Depends.
Well, that's what makes it absolutely easy. You just define another set of rules for relating those two things.
No, but if you have underlying ontological commitments that are inconsistent, then you're going to run into problems.
That's what rules are for. For instance,
We're getting some background noise. Trying to figure out who that is.
not me.
That seems to help. Did I cut someone off?
You must have.
no. But
Okay.
in response to the concern
No.
about incompatible ontologies, I have to ask, incompatible to whom? If you want to build a well-typed, information technology system that's frozen and requires everyone to obey the same rules, yes, that you're right. That's one thing. But take a more typical example, which is just finding out if two data sets ultimately are talking about the same thing in the same way or conform to each other according to certain business rules. That doesn't require an ontological harmonization. That just requires reading data from one source, making some rules about one structure, a subgraph, if you will, in one system, and making the rules that say when that's compatible with a subgraph from another knowledge graph.
Right. Well, you're just introducing a workaround for the ontological and other incompatibilities, which again is a practical solution to the problem.
Yeah, but I'm just wondering what the practical problems of ontology harmonization really are, and if they're even
lots
necessary.
of them. It depends how deep analysis you want to take and what needs you really have to fulfill. So if you want to try and integrate lots of data sources for a long-term integration as opposed to ad hoc, just introducing new rules, then you probably want to have a better or more well-constructed ontology based on appropriate ontological analysis. I mean, it's not a big deal. It is certainly a little more work than creating an ERD diagram. But a lot of the effort that goes into creating those ERD diagrams can be extended directly to include the ontological analysis. Even so, only cursory ontological analysis, you could still have a better result at the end for long-term use. Now, if you're not worried about long-term use, then who cares?
There was an occasion where I was looking at an example of long-term use. This was a database for my university, Northeastern. And it was really interesting to see what happens to a relational database over time. Because the rules, as it were, I mean, that what they had continually changed. But instead of revising, okay, changing, completely changing the schema, what they did is just added new attributes. So the same concept was repeated multiple times in the same table. And you can imagine what the programs had to be in order to cope with this multiplicity of a single concept being multiply represented. So over time, I mean, the thing just got totally unwieldy.
Yeah, there's lots of examples of that, Ken.
So yeah, it was just interesting. Yeah. This idea of interoperability isn't just between different systems. It's between a system now and a system 2 years from now.
Yep. That addresses the scope, and that's what I was getting at: long-term use.
Long-term use is, I think that's a good point that you made about long-term use.
And the cost of maintaining those sorts of situations that you suggested, Ken, can become almost more than replacing the whole thing.
Right.
In terms of things that break and trying to add on new things where you have to start jumping over more and more hoops.
Right. Yeah. I mean, it's just the.
And then the other thing you probably ran into is people made changes and they fail to adequately document them. So you're sort of guessing at what the intent was and trying to infer from what the code is doing what they should be doing. And that itself is quite expensive. And John's wonderful example of how they reverse engineered some COBOL code because it had become too expensive to try and maintain it and extend it because of all the patches and hacks that had been put on in place.
Right. So, I mean, what I found was that the rules, right, the semantics of the system they didn't document anything.
Yeah.
It was all, in program code. And it was in COBOL, but the documentation was non-existent. You just had to know, you had to talk to somebody.
Yeah. And that's why I'm saying using an ontology, you can make some of that, probably not all of it, but a lot of it, hopefully, quite explicit if you've done a decent job. Of course, you can do a crappy job too. And it will be just as useless as a relational database without any good documentation.
Well, one could argue that it's a little easier to evolve.
Oh, yes. Well,
to replicate, to have, 5 attributes, all really specifying the same thing.
Well, the evolution in terms of long-term use can be a problem. If you've made certain ontological commitments that become inconsistent with extensions you want to make, then you do have to do some work. And depending on how you are actually making use of the ontology in your overall IT architecture, that could not be a big thing or could be a major thing.
Well, it'd be interesting to compare if there was a case where you could compare the two approaches, what would happen? Look at a relational approach to a problem and then look at the knowledge graph approach to the same problem.
Oh, look at
Has anybody ever tried that?
Well, I don't know of any explicit comparisons, but the situation that comes to my mind right now is things called product data management systems. PDMs, and they're all based on relational databases, and they have certain notions like part that they just use willy-nilly all over the place. And the interfaces to those PDMs introduce semantic ambiguity and confusion. It would be very nice to see one of those replaced by a graph, an underlying graph database, but I think for those suppliers of those PDM systems, one of which is in the Massachusetts area, whose name, Parametric Technologies. I don't know if you're familiar with them. I think the cost would be outrageous.
Well, it's deeper than that. This is Paul again.
Hi, Paul.
Because no design and manufacturing firm just runs their whole business on a PDM system. You have the PDM system that designers use. You have the shop floor system that the manufacturing side uses. And then you have the logistics planning system that the buyers and the supply chain uses.
I know. And then
they all have their own definition of part and assembly and alternates and substitutes.
Yep, I'm familiar with that scenario.
And that's exactly the environment to which I applied this to. You know, so what, the SAP defines an alternate in one way, and the PDM system defines alternates in another way. At the end of the day, we shut the lights off in the plant. There's data sitting in databases, and you can write rules around that. And you can say, does my PDM system match my logistics system in this respect?
I'd like to make a comment about the problem of ontologies. Ontologies create silos. And when you have different ontologies, you have independent silos, and they can be a barrier to interoperability. So that the basis for that is why WordNet and ordinary English dictionaries and terminologies have always been so much more successful for interoperability than any kind of formal definitions, because a formal definition is incompatible with other formal definitions that may be different. And the very informal ordinary language is the basis that people use for interoperability. And the way that you and when you have different ontologies, aka different silos, what you do is ask questions, so that by asking questions you can resolve the differences between different people. And the same thing is true of different computer systems. You need some way of asking questions. You start with the very vague ordinary definitions in ordinary language or in WordNet and such resources, and then what you do is drill down to see where there happen to be incompatibilities. So I think that starting with vagueness is much more practical than starting with a formal ontology. If you have your own formal ontology and you go to look at anything else in the world, everything else is incompatible. And what you have to do is start with a vague position and then drill down to see where the incompatibilities are. The problem with formal ontologies are, by definition, silos. They create a silo where each formal ontology is incompatible, at least in some extent, with every other formal ontology. And the only way to, in order to resolve them, you have to start with something common, and that commonality is vagueness. It's a vague definition in ordinary language, and so on. So I'm not arguing against ontologies. I'm arguing against using one formal ontology to try to interpret another formal ontology.
Well, John, what do you mean by formal ontology?
What we've been talking about forever. Anything you define in any version of logic is a formal ontology. And logic is designed to make things very sharp, clear, precise definitions. Every formal ontology is a silo compared to every other formal ontology. And by definition, BFO is a silo to the rest of the world. And you can say, oh, but if we all agreed on BFO, then we would all have something basis. No, because as soon as you start adding anything to that very tiny little top level, you've got incompatibilities. And the basic problem is, how do you reconcile those incompatibilities, because the more formal you make it, the more rigid, more brittle, more breakable it becomes. And when you've got it vague, it's like like a wooden house that sways in an earthquake, whereas the stone one falls down. And so the more precise you make it, the more fragile it is. The more vague it is, the more it can withstand shocks and earthquakes and incompatible systems.
But John, doesn't the need for vagueness or strictness depend on the uses? So for
Absolutely.
Instance, I wouldn't want to use vagueness when I go to my bank and ask, well, what's my balance? And, you know,
absolutely.
So
but the point is that when you go to that, no two banks ever have the same ontology, and whenever you see all these bank mergers, they never combine their software. What they do is when one bank buys out another bank, it continues to run on both systems simultaneously for years until gradually one or the other dies away. That's the way they make them compatible. They make them compatible at the vague level, where all you know is that there's a checking account, and at the very, very vague level that you can transmit data across from one bank to another. That's a very vague version.
Well, in any case, no matter what mechanism or paradigm you use, there's going to be some interoperability and or silo issues. And the question is, how can you attempt to minimize those or mitigate them to some extent? And
So,
I would argue...
Hi.
There's someone who wants to talk.
I'm sorry,
Yeah. Hi, I'm Jeanette here. I've been listening to all these interesting ideas. I'm on the kind of practitioner's side. I met Ken before a few calls ago. So in fact, in my company, I work for a very big bank in Canada. Because I know that these calls are being made on the public, so I don't exactly want to, say out loud exactly which bank. But I just have a few opinions here, because I think in a large company, for example, one thing I have learned that when we are trying to establish ontology within the bank and we see some value, is the fact that really different business groups, first of all, different business lines. And we're talking about many people within one business line, right? And you have typically 4 or 5 different business lines in a huge company. And then you have many teams within that business line. And what we found out is that, let's say, take the notion of an active client. What do we mean by active? So what we found out is that sometimes, first of all, different business lines may have different definitions. And not only that, even within different projects, within the same business line, they apply different definitions depending on their need for that particular project. Now, but having said all of that, so I agree with what John was saying, there is that core. That core is minimal, is very small. But what I am hoping is that we have a disciplined way by applying ontology, the techniques, the ontological thinking and all of that, and create this disciplined extensions to that vague core, if you will. And I think there is a lot of goodness in that. And because, as an example, as you mentioned earlier about data warehouse, not only are there, is there this data warehouse, but people who know the rules of the data warehouse are retiring. Many of them carry that knowledge away. They will leave the company. So actually it's an operational risk. When knowledge like these are not being handled in a more disciplined manner. So what we are hoping is to leverage ontology to achieve that disciplined growth of defining these important concepts, which are reusable in many, depending on which piece you want to pick, right? Are reusable in many projects. And the last bit I wanted to add is, as you know, many companies today are on the AI bandwagon, right? And we do data science and all of that. And one observation I have is many of these people who are running data science stuff, they are new, very young people, because I don't think the data science or discipline in university existed, at least not when I was there, 30 years ago or something, 20-something, 30 years ago. So the point is, these young people, they come into the organization, they have a desperate need to understand what does this mean? What does that mean? These core concepts that they are supposed to do some data science on. And so by having this disciplined way of of managing our concepts and knowledge, we are hoping to help our product development.
Yes, Janet.
It is from a practitioner's perspective.
Oh no, excellent points. I think the important point there, even if you don't have an explicit ontology, if you apply some of the techniques from ontological analysis, that you will come up with definitions that may annoy some people, but will probably get or gain a better consensus.
Yeah, and we actually were not so much thinking about. I was learning from another professor who sometimes attends this call, Professor Gruniger. He mentioned about there is this phrase called diversity without divergence. It's a phrase that we quite like, because it means that we have a realistic need to accommodate these different thinking, because business operates in a sometimes in a very flexible way. You cannot nail down, and it would be completely hopeless to get 70,000 people to agree on the same definition. But that does not mean that you grow in an ad hoc, completely organic manner, right?
Yes.
Yes, yes. And I want to emphasize that a rigid top-level ontology is useless for many of these things. That the things that are the basis are the standards that are adopted for particular purposes, such as the standards for transmitting electronic transmission of the information among the various banks. They all agree on certain kinds of things at a level that is sufficient for transferring data, the money and the information about who did it and why and so on, but they don't get down to the very details of how each bank itself operates. And that's where the incompatibilities come in, and all the details you have. They all have checking accounts and saving accounts and loans and mortgages and so on. But when you get down to the detailed specifications, you have pages and pages of specifications of the details, and there's no agreement on those details. And so you have to start with that vague level that is suitable for the transmissions of data. And when you try to get to force a universal set of primitives on top of everything, what you get are silos. And so the problem is that you're never going to get universal agreement at these low levels. You can just get the universal agreements at the level that is adequate for the communication that's necessary. And it's usually islands of adequacy rather than a universal top level.
Well, John, that's probably true, but you can, if you don't want to explicitly use some of these top level or foundational ontologies, you can use them as part of your analysis. It can help you identify distinctions that probably should be made.
Okay, distinctions, that's important. And individual distinctions are always very important. But what happens is that people system builders build a whole set of individual distinctions, and they say, here is my silo, which has all of my distinctions organized in a very tightly knit form. And some other people may have some subset of those distinctions, but they're tied together in a different way. And that different way of tying them together is what creates the problems.
Yeah.
So I'm not against ontologies. You need ontologies, but for interoperability within a given enterprise, you have an enterprise ontology. But even within that enterprise, you're going to have a different branch for the billing and accounts receivable and all that, from the engineering ontology and from the research ontology, and the ontology for for last year's products versus next year's products. They're going to be different.
Right.
And
that's have an architecture for them.
There are going to be architectures, and one of the problems are that the people who are talking about ontology standards, keep talking about these rigid top-down level things. Those are barriers to, those are recipes for silos. Now, I certainly support ontologies, and you do need a complete ontology for a particular application, but The problem is that that when you get across from one application to another, even within the same industry or within the same enterprise, you're going to have serious problems of interoperability. This happens constantly. Now, the thing I'm arguing against is the idea that enforcing a monolithic top-down, such as the kinds of things that are proposed for this proposed ontology standard, that's not going to promote ontology, that interoperability. That's going to promote silos. It's not promoting interoperability.
It seems like what's been coming out here in what Paul said and what Jeanette said, and actually what John and Todd are saying, is the human beings need to have the ability to do ontological thinking, to ask the questions, to do deep analysis in their development, to understand how to develop artifacts as needed to achieve their purposes. Now, if they can have foresight to say, we will want to follow these rules 10 years down the line, and all of these other divisions and all these other industries, whatever, will want to follow the same rules. Maybe that's fine, but what we've found is that usually doesn't work, and that trying to set the rules in stone, people just work around them, and then you're worse off than you were before. So the difference between ontological thinking, I think, is versus ontological artifacts, which are rigid and have constraints on their usefulness. Yeah, there's always a trade-off. That's what we're dealing with here, is that there's a trade-off between if you fix something, you can leverage it, but if you fix it, then you lose flexibility. So
well, I agree with that point, and then just as an example that I keep using, and that is one of the most successful ontologies that has been used for half a century is the hotel reservations, airplane reservations, and all that. And that is based on an ontology that IBM designed in 1959 for the Strategic Air Command for monitoring airplanes across North America during the Cold War. And that then became part of the Sabre system for airline reservations for American Airlines. And then that became part of IBM's airline reservation system that was very widely used. And then that ontology got adopted by the hotels and the car rentals and everything else. And today, every time you're making a reservation for anything, a car rental, an automobile, an airplane, whatever, you're using the same ontology that the IBM guys designed back in 1959. And they really didn't have a complete analysis of everything, but they did do a fairly good analysis of airplanes and how they went, and then that was extended for the Sabre system for airline reservations, and those concepts are still in existence today, and that's the way ontologies evolve, and they support interoperability worldwide for making reservations about anything. Now, that's an example of a successful ontology that was developed in a very ad hoc way without any formal logic and strictly from a very narrow level. Nobody had a top level definition of process and entities and attributes and mereology. None of that was present. It was all started with just looking at airplanes and how they work, and then adding reservations and the money and so on. And little by little, it built up a very substantial body of reservations that is never going to change. You'll never change that. That has survived for 50 years, and it's going to survive for another 50 years at least.
So, John, are you arguing that we shouldn't let humans off the planet?
No, I'm arguing that we should give people some tools that enable them to do this kind of analysis and work their way in. I agree with what Janet was saying about enabling people to do this kind of work and teaching them how to do the work, but the best way to teach them is to give them a tool that enables them to carry on this dialogue so that they can they can start from just a very vague way and work their way through using mostly ordinary language and a minimal amount of structure that enables them to add their new piece of the pie into the slot where it fits.
Okay, I'm all for, I don't mind ontologies, but I thought we were meeting here to discuss knowledge graphs. So
Well,
maybe if we
knowledge
could
graphs, one thing that's great about knowledge graphs
refocus the discussion on what what the relationship between knowledge graphs and ontology is.
Every knowledge graph has an ontology, implicit ontology, and usually it's a very vague one that is at the same level as an off-the-shelf dictionary or WordNet.
And that's fine, but you say it as something bad.
I'm not saying it's bad. I'm saying that's the starting point.
Right.
And that, but the thing is, if you want to take a knowledge graph that uses the level of precision of a typical dictionary, that's where you have to start. And I would say that for any kind of application, you start with the level of common knowledge that is embodied in your typical dictionary or WordNet. And then when you want to use your knowledge graph to communicate with, say, depositing money in the bank or transferring money from one bank to another bank, then your knowledge graph will have to interact with the very highly structured formalization of each of those banks. That's the problem of interoperability.
Not denying any of this, but if we look at the full range of use cases to which knowledge graphs can be applied, I think we'll find that there's a lot of different levels of data integrity, ontological analysis and strictness and validity. And as a community of practitioners, maybe we would do more for the art if we identified those various aspects and use cases for knowledge graphs.
Absolutely, I strongly agree. And the use cases for knowledge graphs are identical to the use cases for ordinary language. And the ontology for a knowledge graph is your typical dictionary. It's basically the knowledge graphs are as precise as what any ordinary speaker of English uses it, and maybe working within a particular actually, when we talk about speakers of English, or you talk about the people who work at IBM will use a different subset of English from those who work at Microsoft or Google or Apple or Amazon. They all have different dialects and of English that are added to or constrain the basic dictionary you get, the basic thing you get from ordinary language. So I'm saying that the knowledge graphs are successful because they're vague.
I think Todd this is Janet. I think Todd made this point a week ago or so. It's the interpretation that's vague. It's not the data is precise. I think we need to add an articulation of another distinction here, another level of insight, or another set of views, that the data is precise. It's the interpretation of it that is not, where the ambiguity comes in. And then there's a question of, the implicit ontology in any data set, knowledge graph, has constraints on its generalization, on the ability to generalize from that one, instance collection to the next, whatever. That is where I think we need not just theories or formal theories are precise and data is vague, but formal theories are precise, data is precise for what it is, but how to generalize it is ambiguous.
Well, Janet, did you mean the actual data or the labels that are used to distinguish the things that are called data?
Well, I think in each of those cases you have something that's precise, and I like the idea of use cases, and I think getting to the actual, you know, I think this is part of what we should be doing is looking at the, you know, from the technology side, through the logic, through the conceptual, through the implementation of any kind of insights to create value. I think we need to tie all these things together. In every situation, you're going to have precision and fixedness. And then how you connect that to something else may or may not be itself fixed in a rule. You know, that kind of thing. I don't have answers to these things. I just think there are questions that need to be addressed.
Well, can we agree that the use of knowledge graphs and or the development of ontologies is an engineering endeavor?
I have no idea what engineering endeavor means other than it's designed for some particular application, and that depends on whatever engineer happens to be working on whatever application for whatever purpose. So the thing is that, well, I noticed that Paul Tyson said that there's that knowledge graphs go far beyond ontologies. I would say no, every knowledge graph has an ontology that's implicit in the mind of the person who wrote it, and that the knowledge graphs use the same ontology as the natural language of whoever happened to write that knowledge graph. So it's not that they go beyond ontology. You can't go beyond ontology. There's always an implicit ontology of the speaker or the writer or the author, and the question and the ordinary dictionaries that you take off the shelf or your WordNet, those are the things that are sufficiently vague that they can cover the ontologies that most people have in the back of their minds and that they use whenever they're talking or writing or doing anything. So there are these vague ontologies, and knowledge graphs represent ordinary language ontologies. And then when we try to use knowledge graphs and interface them with some system that has a precise ontology, let's say a banking system, the banking system will use ordinary English for between a human, a customer, and a teller, and then they'll use a more formalized version when they're sending the electronic transmissions between banks, and then each one inside the bank, they will have a multiplicity of different applications, and every application will have an implicit ontology that was designed by the programmers who wrote that, and they typically have multiple programmers who use different ontologies in the back of their minds, and when they get clashes, you get the typical bugs that are inevitable in all these things. So you can't get away from ontologies. They're there.
John, admittedly, all artifacts are the product of a human mind that has some ontological viewpoint of the world. But
right.
Take say an RDF graph that has no type assertions and no subclass of assertions.
Right.
What's ontological about that?
What's
ontological?
What is ontological is the ontology in the mind of the person who wrote that.
Okay.
And there is an implicit ontology.
No dispute about that. What's ontological about the graph itself?
And your dictionaries, your English dictionaries, are vague enough that they cover that. They're. If you want to know what's the implicit ontology, it's whatever you find in an ordinary typical dictionary that you use for analyzing that graph. It's a vague ontology.
But John, I have a question. I have a question on that. What is additional information you need in dictionary to make it an ontology? You need some notion of how these items that are listed in dictionary are related to each other.
Well,
how far away they are in relation, strong relation.
WordNet is an example. WordNet and Roget's thesaurus, these are two attempts to take an ontology of ordinary language, in this case English, and to put some structure on it so that you can use it for a more computable way. So I would say that the dictionaries try to capture everything that anybody says, and that is the basic source for the definitions that we used in your knowledge graphs. Then if you want to make it more computable, WordNet and Roget's thesaurus are two examples that put more structure to it. But if you want to get to what people call formal ontologies, then you want to get to the place where you have these defined in some version of formal logic, such as OWL or common logic or whatever.
A question.
I got it.
A question that just occurred to me, and it's an implicit assumption I make all the time about knowledge graphs. Are we assuming that knowledge graphs are going to be employed for the use or in use or by use by reasoners, or just knowledge graphs where they're going to be able to make graph traversals in order to satisfy queries? I think that's
reasoning. If you, in order to answer a question, you're doing reasoning.
No,
it may be kind of vague reasoning, but it's reasoning.
Okay, well, I'm thinking more of formal reasoners or reasoners based on either some variation of some fragment of logic, first-order logic. So are we assuming that, hold on, are we assuming that knowledge graphs have that capability or not, or either? That is, they could support both?
People use ask questions about knowledge graphs. They're used to transfer information between different systems, and they're used to answer questions. So they are used in a kind of informal kind of reasoning. And there's no such thing as, and there's a continuum between the most precise formal logic and the vaguest sort of kind of thing that you'll find in a comment or a tweet or whatever. And it's a continuum. And some, if you get to the computable forms, you get to versions that are more and more formal. And when you get to your typical tweets that come out of somebody's tweet box, you get very informal. And the idea is that you can use graph representations that span the full range from the most informal to the most formal.
Well, the question I posed was for everyone who's on the call or involved in this discussion. Are we concerned that knowledge graphs can support more formal reasoning or not?
Well, you know, I've been using knowledge graphs in an application, in a robotics application, and I use it for things like joint positioning, certain animations, how to connect. Like when the robot waves hello to you, that's done it through, you know, in RDF, where I have the joint positions of like the elbow, the hand, and the meaning of that animation, so users can find it later. And if they want to connect, like say a waving action with a smiling action, they can do that. And in the knowledge graph, I have the information whether as to one moves the mouth and the other moves the arms, so those two can play at the same time, those two animations. So
okay, you have an ontology. That is a very precise ontology. The ontology is specified by the people who designed the robot. That is your formal ontology, and every inference is based on the ontology of what the robot is capable of doing, and that's implemented in a computer program. It's very, very precise, and the things that people are saying are interpreted by the robot in terms of its own ontology. And when the robot does something that the people didn't expect, that's when the people revise the ontology in their head to conform to the ontology of the robot. That's the kind of thing that happens when people talk to other people. They have the two people start with different ontologies, and as they talk, they recognize where the communication breaks down, and they keep revising until they get to a shared ontology that is adequate for whatever operation or activity they're engaged in.
Yeah, you know, when I started this, I wanted to find a shared ontology that I could connect all this stuff up to. So you know, I searched around, looked all over, and there was kind of absolutely nothing. I couldn't use part of if I wanted to connect the elbow to the hand. I need to use a spec of part of. So I ended up creating bodily connection connected to physically, and then put that under part of, which, you know, that actually is quite the meaning of part of. You know, part of can mean it not physically and so forth. So anyway, I started out with having exactly what I needed in my own namespace, and then looked to see if I could find some sort of common uppers ontologies that I could map to. And the only thing I could really do was, you know, map it, but I wouldn't, it was never correct. I could use like al same as, and that wasn't correct. So anyway, my point was yeah, there is a problem. I actually expected part of up there in the ontology to be vague.
Yes.
And so even if I don't necessarily agree that it's vague like English, I mean, a lot of, like, my ontology wasn't vague at all. It was very specific.
You have an excellent ontology. What you have done is excellent work in ontology, and you didn't happen to state it in any kind of a formalized way, but what you have is an ontology of your robot, which you implemented in your computer program, and you use your ontology to interpret any English statement that happens to be spoken to the robot. So I would say that you're doing some very good work in ontology, and this should be taken as an example of how we as people working with ontologies should design our tools. We should help people like you rather than hinder your work. So what you say is the work you found on ontology was not of much help because they were all trying to force people into these rigid set of primitives like part of, defined in terms of mereology. And the word part of has a huge number of different definitions. If you look in your English dictionary, you'll find all kinds of definitions for part of that do not correspond to what most like BFO or some of those things, their definition of part of is just something that came off the top of Barry's favorite ontology, and it's irrelevant for the applications that you happen to have with your robotics. So I strongly agree with you that what some of these formal ontologies are doing is of no help to you. And what I would emphasize is that what you're doing with your design is developing an ontology, and we as ontologists have failed to provide adequate tools to help you do it.
Well, you know, in a way, I started out with what I knew exactly needed to work. And so if I never would have used ontology at all, I could have still had it operational. But, you know,
I agree.
Came into it as not necessarily selling a buzzword, but I needed to be able to compile the code, have a physical thing that they didn't have to mess with, but I wanted to give them some stuff that they could actually manipulate using like Protege and as well as a couple other configuration tools. Mostly it turned out to be text files and so forth, where they were editing Turtle or N3 files. But I didn't want to ship a database to run the robot. So the way it worked was it loaded the Turtle files and the N3 files, and that's how the robot would begin acting. And so in that way, it was really nice, because if I was to throw out all that software and rewrite it, I wouldn't have to change the configuration and the things that the users had learned. Oh, this is how I make the robot do X, Y, and Z. They could continue to use their same data format that they understood. That wasn't simple. It was painful, for them, but it sort of made it to where if they didn't have a physical robot, this actually was a use case, but they only wanted to have it on the screen in this 3D animation program, they could use the same exact config and watch it in 3D space instead of in physical space. Okay. So, that heterogeneity is nice.
I
mean,
think what you've done is an excellent use case for ontologists. I think the ontologists have an awful lot to learn from your use case and learn that what they have been doing with all these top-down level ontologies is the wrong way to go. I think the ontologists should be working with people like you who have a real problem to solve. You've got an engineering problem, you've got a robot, you've got things that it can do, and you've got English words that you want to attach to the things that it can do. And unfortunately, the people who have been defining ontologies and are worried about all these philosophical issues that are totally irrelevant to your practical problem.
well, you know, as far as the philosophical issues of let's organize something by, you know, in English, we're going to organize English differently than we're going to organize the joints of a robot and various things. And so one thing I really liked about Sci-Corp's methodology, they have a user interface ontology. They have an explanation ontology that looks at things differently than the physical world might look at it. So like we might organize the physical world in one way, but when we explain the physical or giving a proof or a description, we explain it in a different way.
So are you using Psych? Are you working with Psych and Sci-Corp stuff?
Oh, I came from a psych background, so.
Oh, excellent. Then you've been using ontologies for years because Psych has the largest formal ontology in the world. And one of the things that I keep saying is that all these people who are defining these standards are ignoring the work that has been done for, let's see, they started in 1984. This 35 years ago, they had been developing a huge amount of work on ontology. They've got 35 years of practical experience, over 600, let's see, at one point they had something like 600,000 axioms or millions of axioms. And it's really to ignore that work and go and define these rinky-dink little things like BFO. I mean, I look at BFO and compare that to Psych. BFO is rinky-dink. It's just a teeny-weeny tiny toy. And Psych has practical work, and I'm very happy to hear that you found Psych helpful because that's what I've been trying to tell people. You have to develop a lot more stuff than just some rinky-dink little top level. That is just trivial compared to the work that has to be done down in the trenches in order to make a working application. And I'm very happy to hear that you found the Psych work helpful because Psych is the biggest example of a formal ontology, and anybody that ignores that does not know ontology.
Well, you know, Sci-Corp has violated probably every sensibility that most people have in ontology. So we have an application data context that has a specific application ontology, and then we have a generalized ontology that, you know, is how people want to think and talk about things. That doesn't violate people's sensibilities. But then, you know, we have a schema mapping ontology that says this is how we're going to transform a query between a broad microtheory and an application-specific microtheory. So that, and so all the things that you would normally not want to see in an ontology, there is always going to be something that that you're going to need, that the software engineer is going to need, that the ontologist doesn't necessarily agree.
Wait. I would say that everything that a software engineer needs must be in your ontology, and if it's not in your ontology, that's a failure on the part of the ontologist. And my attitude is people who know nothing but a bunch of philosophical arguments are incapable of doing serious ontology work. That includes the BFO. I do not consider that serious ontology work.
Well, I should say, though, Psych is also an application, and it has bits and pieces of application-specific ontology that's very specific to Psych that has no sort of general applicability in the common sense world of us humans. And
absolutely, that's certainly true.
Because 30 years ago, they had to put that stuff in Psych.
Absolutely, because you need to. And when I talk about common sense world, common sense, there's no such thing as common sense for every individual human being has a totally different common sense from every other one. And a person who is an engineer has common sense ideas that are very specific to engineering, and they're just as important and they're just as worthy of being put into an ontology as anything else. And the thing that I want to emphasize is that, now again, I'm not claiming that that psych is perfect. There's a lot of criticism that I've made over the years about psych. On the other hand, one thing I do say about psych is that if you don't understand psych, you don't know ontology. It's a simple fact. This has been there for 35 years. It's the largest ontology project in the world. They've had more than a millennium of person years of work put into that system, and to ignore it is just, anybody who ignores psych does not know ontology. And the fact that psych gets down to the levels of the nitty-gritty of every engineering project is essential, because you need that kind of nitty-gritty in order to make it work. And so that must be considered part of your ontology.
Okay, John, but how do we use psych?
Excuse me.
How do
We've run over our
psych
hour.
in the,
Please.
hello?
Look, we've run over our hour. I would really appreciate, we need to, adjourn this meeting.
Okay, but
so
I just have a question. We heard a lot about psych, but we need to know a little bit connection with knowledge graphs, how people are using psych in knowledge graphs or in knowledge graphs related ontology work.
Thank you, Ravi. We do have to get back to our topic, but in the meantime, I'm going to stop the recording.